So I'm going to introduce myself quickly, and then I'm going to launch into the presentation. I'm here on a sabbatical from the United States for 3 months before I head on to New Zealand and then Spain. And during this sabbatical, I get to just think new thoughts and set a new research direction for myself and my students. And I've been picking up a lot of interesting things already this morning. Drew and I had a great conversation, I think, before this session started. And I'm just going to start with a few highlights of that, actually, because they dovetail nicely into my presentation. Sydney, I think, he had a new term that was new to me, and that is this idea of faith-based safety. And I have to say, I'm not envious of being a practitioner these days because things change in our theory of what works for safety seemingly every day. What I mean by that is, a couple of years ago, you would have heard the term zero injury, and people would have said to you, if you don't have the zero injury philosophy, then you're killing people. And today you hear, if you do have the zero injury philosophy, then you're killing people, right? 40 years ago, you would have heard regulations are the key to safety, and now we're hearing that hard hats may be optional in some locations, right? So what I'm going to speak about today is a scientific inquiry, okay? I'm an engineer by training, and I'm going to take a scientific approach. And I'm going to advocate that, our field really needs more evidence-based theory. So theory that's based on empirical observation and not just an idea that has the chance of changing tomorrow, okay? So safety innovation, what is it? My focus is going to be on hazard recognition. I think I'll see some cringing in the audience because I am going to focus on the person or the worker, but I'll do that within the context of the bigger system. Safety innovation, by my definition, is that it involves developing, testing, and sharing new safety interventions or solutions. Okay? There needs to be that development, the theory of what might work, but most importantly, there must be the testing of whether it does work, and then share it if it works, and don't if it doesn't. Okay? And so what I'm going to share with you is an experiment. I'll talk about that in detail in a bit, but the experiment is the test bit. Okay? And before I launch into the topic of the presentation, I wanted to share something that we might do a little bit differently in my region in the United States. This is not the United States wide, but that is the way that industry and academia partner together to solve safety problems. Okay? So I posed the question, what are the respective roles within safety innovation of industry and academia? Right? I think it's an important question. As an academic, I ask myself this question all the time. And I'd argue that the industry members with whom I work are the ones who understand the problems, okay? And oftentimes have an idea of, well, how to solve the problem or how to make safety better, okay? The academics, we aren't the experts necessarily in what your problems are in your industry. But what we are experts in, hopefully, is the scientific method, how to test things in an unbiased way, and how to test theory to either support or refute theory so that we can move forward based on actual evidence. So when we partner in the U.S., I'll just show you how we do that. The project that I'm going to be describing to you today on hazard recognition was actually the joint effort of 18 different companies and 2 different universities. And the way that it all started was the companies got together through what we call the Construction Industry Institute. Some of you may be familiar with it, some maybe not. Got together and they said, well, what are some of the major pressing problems that we all have, right? And the researchers then engage with this industry team and design a research plan, okay? How are we going to test some new intervention, or how are we going to test a theory? Together we create the solution based on what the new knowledge tells us. And then finally, we test the solutions, okay? So what I'm going to share with you is the outgrowth of that. The industry team who I worked with was really great. I had representatives from 18 different companies from some of the largest multinational organizations in the world, representing Spain, countries in South America, Canada, the United States, China, and so forth, okay? So the work on hazard recognition, maybe some of you are thinking, oh, are we going back to focusing on the worker or behavior-based safety? And I'll say, no, not quite, okay? But I will make an argument, okay? Hazard recognition, it doesn't matter who the person is, what industry they work in. I think there's an undeniable truth that a person who engages with work must be able to recognize what might be dangerous in the environment that they're going to work in, perceive that element that may be around, could be the edge of this stage, for example, perceive that to be risky, decide whether or not to tolerate that risk, and then perform or behave in some way. Now, if you look at that, yes, it's very person-centric, right? It's not talking about the system of safety. But if you look at those 4 steps, the system of safety really defines what actions people will take, okay? So the behavior or the tolerance of risk has to do with the value system and the belief, the shared values, the safety culture, perhaps the climate on that project, whether or not they think their manager cares, whether or not they care about safety, and so forth and so on. So some of these things that we've heard about this morning and many of the leadership style skills really play into when somebody's confronted with a hazardous situation, what do they do? But I'll argue that the foundation of this whole awareness structure starts with hazard recognition. And you can have the greatest philosophy in your organization. You can have really strong commitment. You can have managers who are visibly participating. You can have that value structure and so forth. But if your workers can't recognize what hazards are in their work environment, you're in trouble, right? It's a fundamental skill. And it's not just workers. It takes the designers, the construction planners, the managers, the clients, and the vendors. Everybody involved in the value stream needs to be able to recognize what hazards they may be encountering, that they may be introducing to the environment, and then take action accordingly. And so I'll offer this postulate that there isn't an injury prevention strategy out there that doesn't require strong hazard recognition skills. Meaning, if we can't identify any hazards that are out there, we're inherently unsafe, okay? So another question that I'll pose is, what about safety and design? And in the United States, we have a different regulatory scheme than here with your regulations that require some designer involvement. We don't have that. And really, designing for safety is not gaining very much traction, all right? You don't see it. It's growing at a very small rate, small proportion of projects using the prevention through design or design for safety idea. And the question becomes why, okay? And there's great literature out there that describes some of these things. It's the regulatory environments, the way that we contract with one another in construction, and that's what I'm focusing here on is construction. It is the way that there's resistive attitudes to design, but one of those things is designers' hazard recognition skill. So if you have a designer at a table and they're designing a beam or a column, how do they know what's hazardous about that environment, right? And so that's a skill that we need to improve. So I asked you the question, what's the hazard recognition skill of your team? And this is a question that our research team posed to ourselves. This is the industry members of our team, is how good are we at recognizing hazards? And that was a question that's largely unanswered in the literature. It hasn't been empirically studied. And none of our industry members had a good answer to the question. Okay? And that was something that we decided was a gap that we needed to close. Are we good at recognizing hazards or are we not? And so let's do it here really quickly, right? So you're a worker or a manager or a designer or whoever you might be, and you walk onto a site, okay? We initially think, okay, we're pretty good at recognizing hazards. I'll give you a few seconds, because that's all you have when you enter in a new work environment before you're exposed. How many hazards do you see? Did you get these? You got the heavy equipment, right? So this is an obvious one. You've got a sharp blade, vehicular traffic up here in the corner. You've got an uneven surface that this gentleman's working on. How about these? There's a compressed gas line. There's noise, there's flying debris, there's heat, and there's a pinch point, right? If that sling were to slip and that concrete conduit were to fall, right? If you identified more than half of these, then you're doing better than average, all right? So I'll show you what that actual skill was here in a second. For workers and managers, this includes the members of our research team who fancy themselves to be leading world experts in safety. The skill was 45%, right? Not just photographs. I'll talk about how we actually did this in actual work environments in a second here. But 45% was the proportion of hazards that people could recognize before they engaged with their work, all right? And if you look at designers, and I can go into more detail if people have questions, 38%. In their design, 38% of the hazards were identifiable and identified by the design team, right? So what the team decided to do is we said, all right, we need to come up with some ideas on how to improve hazard recognition skill in the industry, all right? And that would be something that would be across all different types, from workers through managers and so forth. And so what we did is we said, all right, team, let's get together. Let's find all of the different strategies that either we're doing that we think are innovative, that are out there in literature, that are being done in other industries other than construction. Let's look and just think outside the box of what we wish we had that might work. Okay? And a lot of research studies will kind of stop there. All right? But what we did is we down-selected and we said, you know what, we can't test all of these new ideas. We only really have the time and resources to test about 3. So let's pick the 3 that we think are going to be most impactful. All right? And that's what we did. We said, well, what about some form of training and feedback system? What about looking at the way that hazards are communicated? Because if each individual worker can only identify about 50% of hazards, if we get the collective experience and they're communicating well, perhaps we can improve hazard recognition that way. And then finally, we looked at a strategy that would help with management of change. So I'm going to quickly share these with you, okay? And I think that you'll find them to be intuitive, hopefully. And I'm happy to share any of the products with you because they were produced by academic research and they're freely available. All right? Now, all of the different hazard recognition strategies were built upon one theory, and it's not a new theory. It started in about 1970, but it hasn't been operationalized. And here's the idea. It's that every hazard on site and every injury results from the unwanted release of some energy source. Right? It's fundamental, meaning there's gravity energy that was released. You have motion across the site. You have electrical energy from a conduit, etc. Okay? And we said is, you know, maybe this will serve as a mnemonic or a cue for people to think outside of the box, outside of their typical realm, in order to recognize some additional hazards. All right? You can see 10 different energy sources up here, ranging from noise to compressed gas. And the analogy I'm going to use here is that the energy-based hazard recognition theory, this idea that people can recognize more if they understand the plethora of different categories, is kind of the guacamole or the avocado. And the chip are these different strategies that we're talking about. So we built in the energy mnemonics into these different strategies, and we tested them. Okay? So if we try it again, and I tell you, if we look up here, we've got gravity, we've got motion, we've got mechanical energy, electrical, pressure, temperature, chemical, biological, and radiation. Okay? Those are 10. A true scientist will look at that and say, well, temperature and motion are actually the same energy source, but for the sake of the exercise, see what you can do. See if you're any better. All right? So here's another photo. It'll be the same amount of time. Here are some answers. Right? You've got the sharp blade, similar to the previous one, a heat source because that blade's going through the concrete. You have soil pressure adjacent to the worker, dust, and so forth. Right? Now, the idea with the energy-based hazard recognition scheme is that you can look for some things that you might not otherwise have seen. And it's not meant to say, well, what categories do each one of these hazards that I can recognize fit in? But rather, do I look for some things in here? Do I think, oh, there might be some pressure source here? Or there might be a biological hazard that I might be dealing with, or there could be dust, and so forth and so on. Okay? So the first strategy I'll show you here that was built was meant to help people to recognize some of these energy sources. So what you're seeing is a screen capture video of an augmented reality system. A work team, manager, designer, whomever can wander the site. They can click on something that they find to be hazardous. They can enter the energy source associated with it or energy sources, and then they can get feedback from the system. Now, the idea is that a group of workers, a group of managers identified what was really in these environments and the feedback that should be given. And the idea is also that the workforce can work together and collaborate in this environment and not simply do this by themselves, but talk about the hazards they're seeing and learn from each other. The second strategy is this idea of safety communication. Now, this is a very basic event, I would say, or strategy that we use in industry, and that's the pre-job safety meeting, right? How many people use a pre-job safety meeting or a pre-task meeting before workers go to work, right? It's very common. Now, the idea is, you might have heard people talking about leading indicators, which means how often are these happening, who's involved in these sorts of things. But the team thought really one of the key strategies for hazard recognition and communication is how good is that meeting, right? And what I mean by that is, if you were to go and you were to watch a pre-job safety meeting, I think a lot of the elements of your culture can be observed in how that meeting goes, right? If you've got one person leading it, reading off a sheet or off the prompt that they're given to talk about that day, you've got a few people in the back kicking rocks or checking their phone, not really participating in the process. If it's done off on the side or rushed, then you get an idea that that's maybe not their top priority for the day or they're not engaged, right? So this tool really focuses on a variety of different dimensions, ranging from, is the actual job being identified well, to where is the meeting taking place? Is it right where the work is going to be done, or is it off in a job trailer or outside in a common room or where lunch is going to be had, or so forth? All right? And so there are a bunch of different dimensions, and each dimension has the most mature, least mature, or less mature and least mature, and then there are 9 total criteria. And the idea is that the workers actually evaluate the quality of the meeting that they just held. Are they engaged? Are they asking questions? Are they answering questions? Are they coming up with solutions? Okay? And the third strategy is all about management of change. Right? So if you fill out a pre-job assessment form and it goes and sits on a shelf, is that really all that useful, right? It's useful in litigation, but other than litigation, it's not all that useful. So what the workers are starting to do is they're starting to look at the energy sources you can see here, filling this out and using it as a visual cue so when new workers enter into that workspace, that they can see what's there. As the work changes, this can be updated. And the workers can actually talk about the different hazards as they're writing them up on the board, and they own the process a little bit more. So with that, really, that was all just to show you some different interventions that we were testing. Now, the idea is that we think that these would improve hazard recognition and communication, right, as the work goes on, through training, through management of the safety meetings, and then through the management of change. But the question is, does it truly improve hazard recognition, right? So what we did is we adopted a strategy that is used in pharmaceutical research in order to test our interventions, right? So if I wanted to go and test blood pressure, right, that's my dependent variable. I want to test blood pressure and a pill that I think is going to reduce your blood pressure. And you all are the people, are my members of my experimental trial, right? Imagine you're sitting in the United States and it's in February. And I say, all right, I'm going to hand out, I'm just going to give you sugar pills for a while. I'm going to measure your blood pressure. And then all of a sudden, I'm going to introduce this strategy. I'm going to measure afterwards and see if you're better, right? Well, that's a pretty miserable strategy from a scientific standpoint because I haven't isolated any of my variables. I don't have a control group. And what happens if I give my American colleagues these sugar pills and then the blood pressure medication and then the Super Bowl is the next day? Right? Everybody's blood pressure goes up because they ate everything under the kitchen sink, right? So what we do is we try to isolate those variables, and I'll show you how that works. It's okay. So what we did is we went on site and we simply measured. We said, all right, I had my student Alex, he went on site, he went out with one of the management, and we simply observed the pre-job meetings and the discussions that the workers were having. We said, well, what hazards do you see that you're about to encounter? Okay? And what we did is, after the work was launched, workers were allowed to update that as they were going, and the student was simply shadowing the workers. And they said, all right, well, how many hazards did the workers actually face? Now, the ratio of what they identified to what they actually faced is what you see here on the graph. That's the hazard recognition skill, what they could perceive. And we just measured that over time, all right? So each one of these dots would represent one work period, for typically 4 hours before or after lunch. And we did that across 3 different crews and 6 different projects. And what we did is we said, all right, at a random interval, imagine we have 3 crews running, 3 different shadowers going. We said, we're going to introduce this intervention. So maybe it's the augmented reality training platform, right? We introduce the training. Then what we do is we simply measure afterwards. Now, this initial measurement, that's the baseline phase, okay? Then what we do is we measure afterwards. Now, in theory, we think that we're going to have an improvement, all right? So that would be the intervention phase, and that's simply the before and after measurement that I was talking about. That's not a good experimental design. Now, if I take this and I have 3 different crews, and I randomly assign the intervention at a staged interval, something interesting happens. I now have a control group, right? While one group gets the interventions, I have 2 other ones who don't have it yet. Right? And then as the next one gets it, then I have 2 with an intervention and 1 who hasn't received it yet, and then finally all 3. And what I can statistically do is compare what the line should have looked like, if there's a learning curve or something like that, versus what actually happened. All right? And the reason I show you this, our different strategies showed, for one of the strategies, the augmented reality training, showed 45% initial hazard recognition skill up to 73%. And the reason I really want to show you this is an example of a scientific method that can be used in order to test the theory that a new intervention will work, right? So we did this not only on 1 project, but we did it on 6 total projects, right, with 3 crews per project, and then we could aggregate the data and analyze statistically and measure whether or not there was improvement. Now, the most common question that I receive is, does this intervention stick around? You can continue to measure, as some of our colleagues in Spain did, and we saw continuous improvement all the way up until about 80%. Now, interestingly enough, we couldn't get past that 80%, even with all 3 strategies implemented. Right? So there's still room for improvement. If you might be interested in what different energy sources or energy types are more recognized than others, at least I was, gravity and motion are the 2 most obvious. I think people do recognize them. You can see a greater proportion of the time. And then some of the more abstract hazards relate to temperature, pressure, chemical radiation. The number 1 thing missed on construction projects in terms of high risk tasks was excavations, right? Soil. And one of the theories that I have is that if you take standing at an elevated surface, you get a physical reaction to that, right? If you see something moving, a heavy object moving towards you, you perceive that quite quickly. However, workers, and myself included, if I've got an open excavation, I don't have an inherent fear of that. So I think there's something to be studied about this inherent fear versus the things that are added by industrialization. So some key takeaways. The hazard recognition is a skill that can be improved. It's probably not something popular within the system safety theories in that it really focuses on the worker, but my argument is that it is a fundamental skill and we can't ignore the fundamentals. We need to have a good safety system, but we also have to have good skill within the workforce. We are not as good at recognizing hazards as we thought. And that started with our 18 industry members who thought that they were the best in the world at this, and we tried it, and we were terrible, right? And then this idea of energy mnemonics really works well when it's ingrained and people think in new categories. They think, well, what sort of biological things could get me? Now, I live in Colorado in the United States. We have a lot of Department of Transportation workers. The number 1 thing that gets them, snake bites, right? People getting bee stings and having an allergic reaction and so forth. These are not trivial hazards. They are a little more rare, I would say, but they're not trivial. And then the key thing is that the research that I just described really can't be done without a strong industry-academic partnership. And that's something I'd advocate more and more with you all, as most of you are industry members, with your academic colleagues, is really partnering to say, industry members know the problems that are out there, right? And have ideas on what the potential solutions might be. Partner with the academics who can test this and add a little bit of scientific validity to the theory so we can move on from simply the theology of safety and move it more into an evidence-based evidence-based science that folks can use and know is a stable outcome. So with that, thank you.